Hi friends, welcome to our channel. Okay, today we are going to discuss about intermediate first year first chapter in chemistry, atomic structure. Okay, over thousands of years ago, so in the minds of people, there exists one question: what the matter consists of? This is a common question which arises in the minds of people in a long time ago. Is it matter really consists of the particles, or what are the particles present in the matter? And there are a lot of questions arise in the minds of people. For example, so if the existence of atoms has been proposed since the time of early Indian and Greek philosophers, over 400 BC at the time of the existence of atoms has been proposed since the time of early Indian and Greek philosophers. So Indian and Greek philosophers, they first proposed the existence of atoms. They first proposed that matter consists of tiny particles called atoms, and they proposed that atoms are the fundamental building blocks of matter. Means atoms are arranged. Not single atom is arranged in a matter. There are a lot of atoms are present in the matter. So they are arranged like building blocks. They are arranged like blocks, and those blocks could ultimately made as a matter. The word atom was derived from the Greek word atomio, which means uncuttable or undivisible. Means it cannot be divided again into particles. Atom is the ultimate particle present in the matter, and it is uncuttable. We cannot cut into further particles. And but these are just words; they are not proven experimentally. These are just ideas. The ideas of people they said in their own words, but these are not proven experimentally. But these ideas remained dominant for a longer period of time because there was no such technology to prove experimentally. Up to some period, these ideas were only dominant and no experimentally proven activities were taken. But in 19th century, some scientists they further developed these ideas into to experimentally activities. So if we take laddu, if your friend gives laddu to you, what we can do? We immediately eat it. But some people at that time, for example, if we give a laddu to them, they thought that so what is laddu made up of, and what are the particles present in the laddu? They might think like that. So those scientists, those brilliant scientists, they discovered atoms and the further particles in atoms. Okay. Now see who the first person who explained about the atom and is Dalton, John Dalton. He is a British school teacher. In 1808, he proposed Dalton's atomic theory. Okay, in a firm scientific basis, in a scientific way, not only just words. He regarded the atoms as the ultimate particle of matter. Means the atom cannot be divided into further particles. He regarded that the atom is the ultimate particle of a matter. And all atoms of an element are identical to each other. These are Dalton postulates. All atoms of an element are identical to each other in mass and properties. Means, for example, in an element there are so many atoms. One atom is similar to another atom in their mass and the properties. Okay, in the same element. And the compounds are made up of atoms of different elements. The compounds are made up of atoms of different elements. We take Na2CO3, there is sodium atom and carbonate ion. So there are two different elements. They combinedly form a compound. And these compounds, the atoms present in one element and the atoms present in another element, so these are identical to the properties. Here he explained the law of constant proportion. So what the law of constant proportion means, the atoms are in an element, the atoms are present in a fixed ratio. He explained that this is law of constant proportion. And law of multiple proportion is In a compound in two elements, the atom of one element is different from atoms. Properties of atoms of one element is different from properties of atoms of another element. This is law of multiple proportions. He explained in the fourth point, and the third point he explained about law of constant proportions. And the fifth point he explained about a chemical reaction is a separation, combination, or rearrangement of atoms. Means in a chemical reaction there exists a separation of atoms. Means in a decomposition reaction, one compound is separated here, and a combination reaction, two compounds or two elements combined to form one compound. Or rearrangement of atoms, means in displacement reaction we see the rearrangement of atoms. So like this, it does not result in creation or destruction of atoms. Only the separation, combination, and rearrangement of atoms only takes place, but there is no destruction or creation of atoms. Here he explained about law of conservation of mass. Means matter neither be created nor destroyed. It can only pass from one to another, energy or matter. Okay. No, he does not. But some limitations in Daltons is he does not explain about subatomic particles which discovered later period. He explained that atom is indivisible, but after some period it is proven that atom is divisible. There exist subatomic particles, but he does not explain that. And he failed to explain results of many experiments. See, when we take a comb and we comb the hair after the bath, what happens when we take the comb near some paper pieces, it attracts, means electricity is generated. He explained, he does not explain why that happens. So in an atom there is no particles at all, and how the electricity is generated. We know that electricity is generated due to electrons, but he did not discover electrons at all. So it failed to explain the results of many experiments. It is example, I said one example. There are a lot of experiments also. Like this electricity is generated. Now this is Dalton's atomic theory. Okay. He explained about law of conservation of mass, law of constant proportion, and law of multiple proportions. Don't think that he does not explain subatomic particles, but his theory, his first theory, almost what he said is correct, but he does not say a new things. But what he said is correct, except that atom is indivisible. Okay. It is the first basis for the other scientists also to look out the atomic theory deeply. So we have to appreciate the Dalton's atomic theory. Now discovery of electron. So after Dalton said there are no subatomic, the atom is indivisible, but some scientists like Michael Faraday showed that if electricity is passed through a solution of an electrolyte, chemical reactions occurred at the electrodes, which resulted in the liberation and deposition of matter at the electrodes. This is the cathode ray discharge tube activity, which we will discuss. So, if electricity is passed through a solution of electrolyte, when we take electrolyte and the electricity is passed through the electrolyte, chemical reactions occur. We know that electrodes means cathode and anode. Chemical reactions occur at cathode and anode, and which resulted in the liberation and deposition of matter at the electrodes. The matter will deposit at cathode and matter will deposit at anode. This results. And after the discovery of discharge tube in 19th century, subatomic particles are discovered. So after the discovery of discharge tube in 19th century, the subatomic particles were discovered. Now what is a discharge tube? A cathode ray tube or discharge tube is made up of glass containing two thin pieces of metal called electrodes sealed in it. So it is typically a glass containing two thin pieces of metal containing two electrodes, cathode and anode. So let us see the photo of. So this is a discharge tube. It contains two electrodes. One is cathode and one is anode. These are two electrodes. And evacuation or vacuum pump. And high voltage, it's battery, high voltage. This is further experiment diagram. Okay, let us see this initial diagram. Now let us see the discharge cathode ray experiment done by Michael Faraday. So at very low pressures and high voltage, cathode rays are generated and travels from cathode to anode. So when we take, these are two conditions. When we take high voltage at the battery, here we taken high voltage at the battery, and in the vacuum pump we have taken low pressure. Keep in mind these 2 points. These are conditions to make the experiment. High voltage at the battery and low pressure in the vacuum pump. These are two conditions. What happens now? The cathode rays, which are negatively charged particles of the cathode rays, are generated and travels from cathode to anode. Means these cathode ray particles, they will move from cathode to anode. These are called cathode ray particles. Okay. The characteristic of cathode rays does not depend on nature of gas or metal electrolyte, which shows that electrons. This cathode rays does not depend on nature of gas, which gas is present in the discharge tube, and metal electrodes. Okay, these metal electrodes, which metal is it? It also does not depend. It only depend only two conditions: low pressure, high voltage. So this shows that electrons are the common constituents of all atoms. Every atom, any gas atom or any metal electrode, the electrons are common parts. Constituent means parts. This shows that electrons are common parts of all atoms, irrespective of which nature of gas is it or which metal electrode is it. Now, let us take an example in our daily life. The television picture tubes are cathode ray tubes in which cathode rays, when fall on a screen coated with fluorescent material, the screen becomes bright. Here, when the cathode ray particles move from cathode to anode, we cannot see the particles. We cannot observe the particles. But when here observe second diagram. But when we coat the screen with fluorescent coating or photophosphorant coating, which is made up of zinc sulfide, example. When we coat the screen with fluorescent coating, we observe bright light. The screen becomes bright and we observe the particles. Only when the screen is coated with fluorescent coating, we observe the cathode ray particles. The screen becomes bright and we observe the cathode ray particles. Same example when we take television picture tubes, these are coated with fluorescent material where the cathode rays fall on the screen and the screen becomes bright. We are seeing the picture. Okay, this experiment only caused for the brightness of the screen, television screen, and we are seeing the television screen. Now, in the absence of electrical or magnetic field, these rays travel in straight lines. So, when there is an absence of electrical or magnetic field between the space, when we cannot take any electrical or magnetic field, the rays travel in a straight line. The rays travel from cathode to anode in a straight line when we cannot take any electrical or magnetic field. But in the presence of electrical or magnetic field, the behavior of cathode rays is similar to that expected from negatively charged particles. How negatively charged particles called electrons travels in a conductor, the same way when we take electrical or magnetic field in the discharge tube also, the electrons are travel in that way. So, suggesting that cathode rays consist of negatively charged particles called electrons. This showing that what the cathode ray particles are consist of negatively charged particles, which are called as electrons. Thus, we conclude that electrons are present. So, this is the discharge to experiment. Now, this experiment proves that all atoms consist of electrons, which is a common part irrespective of nature of gas and metal electrodes. Okay, this is the results is in the 5 points only. The results of this experiment are also given. What it resulted when we coat the screen with coating, we see the bright red particles, and the ultimate result is electrons are present in the atoms, which we see when the screen is coated with fluorescent coating. Which we see that the same way how in a conductor electrical charged particles are flowing, the same way when we take electrical or magnetic field, the electrons are flowing, the cathode ray particles are flowing like the same way which electrons are did in the conductor. These are the results of this experiment. Okay. Now in the next video we will see the charge to mass ratio of J.J. Thomson experiment. Okay, thanks for watching, and if you like this video press like button and don't forget to subscribe. Thank you.